Hello and welcome back to part 2 of the H9 Heathkit terminal troubleshooting and repair project. This is something that if you haven't seen the last video, you may want to watch it first because I will be referring to a lot of things in that video, especially in terms of what problems this particular Heathkit H9 terminal has. Well, in the last video we discovered a couple of things. One is that we were getting a lot of garbage output on the screen, and secondly that it would not do a loopback test, and that's where you take the serial out and reconnect it back to the serial in on the terminal and then operate it in full duplex mode. And when you do that, you should see typing on the screen, and as we saw in part 1, that wasn't the case. So I thought maybe the first place I would start in trying to troubleshoot this Heathkit was to take a look at the serial I/O board, which is what I'm removing in the video now at this point. I should also mention that I did discharge the CRT, or the cathode ray tube, in this terminal before I started working on it. You don't see that in the video because I think there are a lot of good videos out there that can teach you how to do that. And a caution, as always, is do not work on any kind of a CRT monitor or television set unless you know what you're doing. There are some very dangerous high voltages, even when the unit is powered off. Well, with the serial I/O board removed, I decided the best thing to do is to spend a little bit of time with the manual on the H9. So I was looking at the H9 assembly manual, kind of going through it and making sure that, at least visually, that the board looked right, that it had been assembled properly, and it also allowed me to get a familiarization with this particular board. I also had the schematics at hand and was able to look at those and understand a little bit better how the board works and how it interconnects, especially to the other boards in the system. Since I had the board out, it seemed like one of the reasonable things to do would be to clean up all the connectors, pull some of the chips and reseat them, and clean up any dirty pins or anything like that, which I did. And at the same time, I went ahead and got my tester out and decided that I would take some of the logic chips, at least the ones that I could test, and see if there were any problems with any of the chips. I also used deoxit in all of the different sockets when I reseated the chips, so I kind of gave the board a good general cleanup, and in testing all the chips I didn't find any problems. So it was time to reinstall the serial I/O board, and I thought I could do a quick loopback check, so I was going to reconnect the serial in to the serial out, put it in full duplex mode once I got the card installed, and just see what would happen. Now, I didn't really expect this to solve everything because we had a lot of problems with garbage characters and such on the screen, and I don't think that would have come from the I/O board, but it could have been the problem with the loopback. However, when I did a quick test, I found the same results, and we still didn't have a successful loopback test. From studying the schematics, it seemed like the next logical place to turn would be the timing and processing unit, or the TPU. This board seems to have interconnect almost every other board in the system, and almost all data needs to process through that board. So I thought, well, let's pull that out and give it the same treatment that we initially gave the serial I/O board and see if we could find any problems with the board. So in similar fashion to the serial I/O, I did pull all the chips and cleaned pins on those, used deoxit in the different sockets, made sure that all the chips were well seated, and did that for the entire board. Just like with the serial I/O board, this was about a half-hour project, and I don't think I mentioned that with the serial I/O board, but it takes about a half an hour to pull all the chips, clean all the pins, reinsert them, and run the ICs through the chip tester. Now, I eventually did find a problem on this board. Just one single chip. This chip was a 7405, and after running it through my tester a couple of times, I ended up getting the same results, that the chip was bad. So every other chip in the system tested good, well, except for the proms, which I wasn't able to check. But we eliminated everything except for this one 7405, and I kind of wondered, could just a single logic chip cause the problems like I was seeing? This 7405 chip is a hex inverter, and it's pretty well positioned on the TPU board such that I could see that it could potentially cause problems that we were having, like the erase screen or erase page or the erase end of line function. And as you might remember, neither of those functions worked correctly, as we saw in the last video. After replacing the 7405, I reinstalled the TPU and reassembled the H9 unit, and it's time to test it out and find out if we've made any headway on the problems that we were seeing with this unit. Okay, this time turning on the system, there is just a cursor. You might remember from before when I looked at this thing and turned it on, there was just a screen full of garbage, and that's already quite the change. So I think this might be good. So let's go ahead and go through the checklist as it is here in the Heathkit assembly guide and see what it looks like. All right, so first check is press the long space bar several times. The cursor should move each time the bar is depressed. And I think if this is working as before, that should be okay. And there goes the cursor across the screen. And then depress the cursor right arrow side of the keyboard several times. The cursor should also move. All right, simple enough. Press the left arrow key and the cursor should move back. Press the down arrow key. Oh, a little bit of a debounce issue there. Okay, and up, so up and down. That looks good. Push several lettered characters. Each character depressed should display on the screen. And indeed it does. And now depress erase page. And if you remember, when I hit erase page before, it put a bunch of lines of text across the screen. So now if we do erase page, page goes dark, cursor returns to the top. I think we might have it. Now it says depress the transmit key and the cursor should continue to move across the screen. So transmit page. And there goes the cursor. And it moves down to the next line. So depress several character keys. As you do, those characters should appear where the cursor was. And sure enough, it does just that. Okay, now depress the break key. That should stop. Now hold down the control key and press the G key. And I should hear a beep from the speaker each time it's depressed. And we do. Okay, now press Control H and the cursor should backspace each time the key is depressed. Control H. And it does. Hold the control key. Okay, we did that. Depress the home key. The cursor should move back to the upper left part of the screen without clearing the screen. All right, and so our home key is right here. And it does, so it leaves the screen. alone and moves the cursor back up to the corner. All right, now hold down the L key and repeat. We should see a line of characters. And we do. One thing I do notice though, and we noticed this kind of the last time, it does go downhill a little bit, so we're going to have to make an adjustment there. Okay, now next hold the left arrow and depress the repeat key, and now it should move the cursor back, which it does. Now if we press erase till end of line, it should only take from the cursor over, where you remember what it was doing before is it just filled the whole line of whatever character it was sitting on. So let's do erase end of line, EOL, and it works perfectly. Now we want to erase page, and works just like it should. Now next, push the alphabet keys in order. Okay, push the plot button. All right, and now it says to press the alphabet keys in order. All right, so, got a little skip on the W. So what we should have seen is little hash marks, or excuse me, little dash marks in ascending position. So I guess this was a feature to allow you to kind of plot a graph or something on the screen. This is not a feature that I think would be used much anymore on a terminal. All right. Set all the keys in their up position, then set the scroll key to its depressed position. Use the cursor down and position the cursor at the lower left of the screen. Oh, I forgot to set the plot back up. Okay. So we want to go to the lower left of the screen. Oh, interesting. I think I see what this does, but let's follow the directions here. Now to press the J key several times, a row of J should appear on the screen. Let's use our repeat key. Now if I scroll, okay, yes, we scroll down the screen. Now hold the control key and depress the J key several times. The display should move up one space each time you depress the J key. So if I do control and J, it does. That's the same as if I would have just went ahead and used the arrow key. All right, set the following keys to their depressed position. Scroll, which we have, short form, auto carry, and baud rate. Now it says hold the repeat key and any character key down. The screen should fill up with 4 columns of characters. Hold a different character key down for each column. The last character in the right column is printed. The display should shift left 1 column. Okay. Before I do that, I'm going to erase page. And now we're going to do the repeat key, and we'll do A. Okay, this is like we saw before. This is the short form mode, so it's going to make columns. And when it moves to the next column, I'll switch to B's. Didn't quite get it there. Accidentally pushed the space bar, but you get the idea. So I fill the next column with B's, and we should be able to do this for all the columns on the screen. And as it said, it will move one column to the right when the screen fills up. So that works correctly. All right. Now the next thing that we need to do is to do what we did before, which was to jumper the serial in and out so that we're basically able to put this thing in full duplex mode. And so we're going to take character out and return it back to the terminal. So let me get that set up really quickly here. All right, so we're still able to do that. Now it says to push full duplex. Okay, so what should happen with those two lines connected is we should be able to type as normal with full duplex down. So let's do repeat. We'll do G. Okay, that's working fine. And let's do a line feed return. We'll type some more. Now what it says is if we pull with it in full duplex, if we pull that wire out, we should not see any characters, and that will confirm that it actually is reading both the serial input and sending the serial output. So we'll pull that wire, and as expected, nothing types. So in full duplex, without that loop back wire, we don't get any characters. Of course, we put it back in half duplex, everything works as normal. All right, so I think we might have it. I think that this H9 terminal is working correctly. It is set up to run 600 baud to connect up to the H8 computer. So two things next. I'm going to try to straighten that text out. Then the next thing is to go ahead and make up a cable to connect this to the H8 and see what happens. Well, this is going to be a pretty simple cable. It is just 3 conductors. One conductor for ground, and then one for serial out, and the other for serial in. And of course, they'll connect to their opposite counterparts on the other system. So serial out to serial in on the H8, serial out on the H8, serial in on the terminal. So with the cable made, it's just a matter of getting everything put together. So I'm going to set the terminal out here and get the H8, connect everything up, along with a cassette tape deck so that we can actually load some software onto the H8. And we'll see if all of this hard work to get the H9 terminal working is going to pay off. So I am going to need to do a bit more testing to make sure that these two units do talk correctly to each other. And you can kind of see how things are set up. And I have 2 cassette decks. I have one for software loading and then one for writing out to tape. So instead of using just a single deck, I've got one for each function. And I do like these particular cassettes. They are computer cassette recorders from Radio Shack. They would have worked with the old TRS-80 and color computers. All right, well, like everything else, there is a specific test in the Heathkit manual that we are to follow in order to see if this is working. And if you watched one of my earlier videos on the H8 where we used a laptop as a terminal, you've seen this same test. So what we're basically going to do is just send a character from the H8 to the terminal and make sure that the terminal receives it. And in this case, we're just going to send the A character. So we're all ready to send it. It's just a matter of hitting the out key one more time. And each time we hit the out key, we send an A to the terminal. So we can definitely see that the H8 is talking to the terminal. So every time that I press the out key, we get another letter on the screen. All right, now we need to set up to do the reverse, and it's the same test pretty much, or the same steps. The only difference is we're going to get everything queued up here, and then we're going to send a character from the terminal back to the H8. So we'll type a terminal character, and then we're going to hit the in key on the H8. So we use the X in this case. So there's our X. If we go back over to the H8 and hit the in key, we can see that we did receive the X character, the 330 that you see on the left-hand side. And if we now hit out, we will echo that X back to the terminal. So the test shows it's good. So we have a good cable, good connection, good terminal, good H8. I think we're all ready to go here, and maybe we can find something more interesting to do. So I think to get started with that, we'll load Benton Harbor Basic. And to do that, it's going to be like watching paint dry. So we are going to speed up the load time. But at the end of this process, I will tell you how long that it took to load Benton Harbor Basic to the H8. So this is what things were like back in the day. For those of you who never had the joy of using cassette tape to load software, it was a little bit of a tedious process. And to just get this thing booted up in BASIC, it takes about 1 minute and 36 seconds. And there we are. We see Benton Harbor Basic, and we are ready to write our first program using this combination of H8 and the H9 terminal. So like everybody does, we're going to do hello world. Of course, me right here balancing against the camera stand while I type one-handed. I wouldn't be much of a good typist even with two hands, and this keyboard on this is really kind of awful. These are not the best feeling key switches, so touch typist I think would find this a nightmare. And there we go, hello world. Well, hello world isn't too fun. So I think what I'll do now is I do have a game that I can load. Heathkit put out a game called Space War, which actually was kind of a revision of an old Star Trek game that was really popular back in the late 1970s. And just like before, we're going to get this thing set up to load Space War, and this is probably going to take longer even than it did to boot BASIC. Now the good thing is these are all text-based programs, so they're relatively short. So even on this slow computer, you're talking just a minute or two to get your software loaded. Now if we moved forward in time a little bit and looked at something like a VIC-20 or Commodore 64 later on, that we're going to have larger programs, maybe 16K or larger, you wouldn't just be waiting around a minute or two. You could be waiting around for 10 or 15 minutes for your game to load. So as bad as this may seem, we can be grateful that it's just a text game. And this took a total of 1 minute and 42 seconds to load this text-based version of Space War. All right, we are ready to go. So we're going to run it. Oops, we have a problem. One of the things when you load a BASIC program, a lot of times they load in what's called a locked condition so that you can't edit them or run them. All you can do is list them. If you just type unlock, that will set things right. And here we go. We are up and running. and I'm not very good, so I'm definitely going to pick the easy level. And all this time that's going by that it looks like nothing's happening on the screen, well, welcome again to back in the day. The computer is actually calculating in the background. It has to generate the conditions for the game that we're going to play, which kind of is to generate the maps, generate where the enemies are on the maps, and that doesn't just happen instantaneously on this H8. So it takes a bit of time. Well, that is Space War up and running, and as much as I would like to get into this game and see if it's like I remember it, and see if I can take and eliminate the Klingons from the galaxy, I have other important things to do, like get this going. Instead of loading things off tape, if I can get this H17 unit to work, I will have dual disk drive with this system. But that's something we'll take a look at closer in the next video. Thanks again for watching, and we'll see you next time.